Okay, this is my summary of Unit 1, Social and Ethical Issues for Year 12, and it's going to flesh out some of the syllabus dot points. There's more detail in the textbook, so do not consider this the absolute be-all and end-all for information, but it does give everybody a pretty good overview of where they should be looking to revise for Unit 1. Okay, so the first thing to do is cover the impact of software. And most of this stuff comes straight from the syllabus, and it should be your Bible that you tick off because they can't ask you anything that isn't in the syllabus. Okay, inappropriate data structures can have significant impacts on society, for example, the Y2K problem. And the Y2K problem was where we had date structures that were built up to be day, day, and then month, month, and then year, year. So 2 digits for day, 2 digits for month, and 2 digits for year. And then we got to 1999, well, slightly before 99, but as 99 approached, we realized that nobody had gone back and rethought those structures, and there was an awful lot of software that could very well get confused about whether it was 1900 or 2000 once the zeros ticked over. And for date functions and a whole lot of financial math, that was going to be a disaster. So there was a global effort to patch all of these problems, and it was a bit of a fizzer in the end. There wasn't a huge impact, but that was, I thought, to do with the fact that there was so much work done. I remember I was just starting out in IT back then, and we had a computer that didn't turn on again because it had refused the patch. And so 486 machine never turned on again after 1999 kicked over to 2000. So people thought the world was going to end. It didn't, but it didn't because a whole lot of people did a lot of work. But there are a couple of those coming in the future. There's End of Time for Unix. You should look those up on the internet. Just knowing that they exist, they're not actually covered in the syllabus. You will not get asked a question about them specifically, but you might get asked a question about how it could impact future systems, and happening to know that there was such a thing as end of time or even running out of IP addresses for the internet is really useful information because you can use it to flesh out your answer. Okay, that's way too slow. I'm going to go a little bit faster through a lot of this. So you have to know that there's malware, which stands for malicious software, such as viruses, and what those different types are. We covered that in a bit in preliminary, and Sam Davis has a lot of text on different types of malware, and so just knowing the difference between some of them is good for rounding out answers. Social networking and the fact that it exists, and that there's privacy concerns, and that there's social concerns, and things like cyberbullying happen. Cyber safety is a thing that's very closely linked to social networking, and it also means that we have to teach children how to be safe online, and then adults can even be scammed online or have identity theft happen to them. And so software developers need to be aware that this kind of stuff happens, so not to email people to ask them to send them passwords, because everybody has theoretically been taught never to do that. Okay, huge amounts of information. There is a ton of stuff on the internet. There's a whole lot of stuff that's lies. There's a whole lot of stuff that's not purposefully trying to mislead but is still wrong. There's a whole lot of stuff that's just opinion, and we need to know how to navigate that minefield and how to guide our customers through that minefield. And reading stuff on the impacts of fake news for the 2016 US election, and Facebook and news and bots, and knowing that those things exist is keeping current enough so that what the HSC writers often do is they try and refer to recent newspaper articles or in general sense, recent news to try and get you to explain how the rules apply in this case. So it means having thought about some of the news articles that relate to software design is a really good starting point for yourself. Okay. Rights and responsibilities of software developers. I don't know, I have the word information there. Okay, so this is what most of your assessment one is going to be based on. There are a whole bunch of rights and responsibilities that are written into the syllabus. There are some rights and responsibilities that aren't written in the syllabus, but you don't have to know those ones. You just have to know what the ones that are in the syllabus mean and to be able to flesh them out a bit. So we've said that the syllabus writers have said that software developers are required to make solutions that are reliable. They are of high quality, they are free of viruses and other malware. They perform the task that was stated correctly and efficiently. And that's important. Sometimes you're the customer who has told a software developer what you want, and then the software developer delivers something. They have to have documented what you wanted well enough so that we can then undergo a quality assurance process to check that what was delivered actually matched what we wanted. And that's why they pushed the structured approach so heavily in project development, because it means that you have exactly what the customer wanted documented and agreed upon before you start spending any time on it and spending any money, because time is money, because you have to hire developers. So making sure that software that is written for a client actually does what was agreed in the contract is necessary. Now, when it's not bespoke software, when it's off-the-shelf software, it's a bit trickier because you imagined a client, and often there was a focus group of people. Well, we'd like to think there was a focus group of people who were potential clients that you were asking to give you information about what they wanted, but in actuality, you're creating software for someone who is a myth. And so you document what you believe your software does, and a user has every right to be able to read that description and know that understand that it's going to do that job and do it efficiently and without breaking their computer. And there can sometimes be misunderstandings between software developers and users, both in terms of bespoke software and off-the-shelf software, in that the user thought it was going to do this, and the developer said, we never said it was going to do that. And so those kinds of negotiations have to be sometimes mediated, but they have to be managed. But a software developer has a responsibility, to the best of their knowledge and with the best communication practices, to fulfill the needs of the user. Okay. Then we have responsible developers provide systems that allow them to respond to problems encountered by users. So there has to be a way for a user who is unhappy that the software doesn't work to be able to get in touch with those software developers. It's not reasonable to just throw something onto the internet and then not leave any contact details. There are some exceptions to this. If you are giving software away for free with no warranties, then sometimes there's a bit of a loophole there, and nobody can expect that that's going to do exactly what they want because they haven't paid for it. But you still can't break their computer, because then civil law is involved and they can sue you for damages that could be predicted, I guess. So be careful about stuff you put on the internet, but also make sure that in user manuals or somewhere in the help or you have to supply a way for a user to get in contact with you or the company in order to have problems fixed. And there is a professional code of conduct, and this is not a magical thing, that these are generally defined per company. So the kinds of things that are in a code of conduct, we will cover one in more detail later on, but the kinds of things that are covered in a code of conduct involve things like sexual harassment. I mean, there's laws, but there's also a company might suggest that people that work together in teams are not allowed to be married or dating. That's a code of conduct. It's not covered by law. It's just an agreed way of behaving in that company. And before you get employment, you are shown the code of conduct so that you can adhere to it. And if you don't agree, not take on the job. There are more software developer focused codes of conduct, and we'll have a look at some of those a little bit later. Okay, acknowledging this is one of your responsibilities, acknowledging the intellectual property of others. It's very important that people have the right, when they write good software and make it available for people to use, that is then accredited to them. So if you go to Stack Exchange or Stack Overflow or even GitHub and you find something that is useful for a project, that you will then and make sure that there is it's not proprietary and you're allowed to use it. Once you've determined that you're allowed to use it, you have to credit where it came from. Unless you pay, there's often a licensing fee that requires a royalty to pay to the software developer, to the owner, to say that you're allowed to use it in a certain context. And that's called a royalty. And sometimes it's also called a license. It depends on what it is. But images, for example, if you go to a stock image site and you want to use one of those images for your software splash screen, you're allowed to, but you have to pay them. And you can, usually they charge you like a bulk lot for 10 or 4 credits, and then you buy however many images you need. You can't generally buy one at a time unless you deal directly with an author. Okay, I didn't go over the Sam Davis definition of intellectual property, but that's covered in the textbook. But you know that authors are allowed to own the rights to who can have a copy of their work. Okay, quality is the measure of the usefulness of software. So it needs to be free from errors. It needs to run in a reasonable amount of time. There are a lot of apps on the App Store and the Android Play Store that don't do these things. So this is a responsibility in the sense that we agree that we're going to try and make quality software, and it's going to harm our employment prospects in the future if we don't, but it's not actually a law that's enforceable in any way. Generally, we judge the quality of software based on the requirements of the software. So that's what we require you to do in the HSC major work. You define all of your requirements up front in Part A, and in Part B, you then make the project, do your evaluation. The evaluation is required to refer back to the requirements that you defined in the first stage. And that way, that's called total quality, doing the whole closed circuit of I defined really carefully and then I assessed whether those criteria were met, is what we define as quality. And it's harder these days when we're moving away from a structured approach. Most new software projects, small software projects, startup type software projects are made in an agile way. And so it's trickier to have that full circle of plan, define, design, produce, and evaluate, and then plan the next iteration. It tends to be a much closer loop than that. Yeah, so it's still there, it's just not quite the same process. Okay, operating system. This is revision, so we're going quickly. It's the thing that provides the interface between the user and the software applications. So it has these main jobs. It has to sit between the user and the applications such as word processing or Excel spreadsheets or even web browser. It talks between the software applications and the hardware. So it manages saving to the hard drive, for example. It manages the interface between the user and the hardware. So when they want to print or when they want to make a sound to the sound card or play music, then the operating system often does that. And it makes sure that when I have PowerPoint running and recording and also have Outlook running in the background and a browser window open, that all of those things are able to happen at the same time. And when I'm using too many resources, it tells me when my battery is getting low or my memory is running out. Operating system. You need to know your operating systems if you're going to write good software. Compatibility. So we have two types of compatibility, and that means to make software that works. Backward compatibility means that it works on old versions of software. So lots of times software interfaces with other software, but it all has to interface with the operating system. So they need to make sure that whether somebody is running Windows 7 or Windows 8 or Windows 10, that your piece of software is going to work. Windows 10 being the most current. You guys are on different versions of Apple. Same thing happens. When you buy a piece of software, you want it to work on several previous versions of the operating system. It can't run on all previous versions of the operating system because of how much management that would take. There does come a time when software companies say, no, we are no longer supporting really old software. And there was a, I think it's last year, or if it wasn't last year, then it's very soon. One of the biggest, the largest deployment, so the most number of people that has a version of Internet Explorer was about to run out of life. So nobody was going to be supporting that version of Internet Explorer anymore, and there was a bit of a crisis, or is about to be a crisis, because there's this huge number of people that still run the wrong version of Internet Explorer, and so that's all going to have to be managed onto the new version. And how do you communicate with that many users and encourage them to do what their operating system has been trying to encourage them to do for ages? Okay, forward compatibility. This is how you try and predict, and that's really hard, but try and predict hardware and software changes in the future and make your software robust enough that it will continue to run even as hardware improves and software improves. And so that means that you are trying to make sure that you're using the resources in a clever way. You are still able to make updates for that software. So it is encouraged as part of the compatibility and quality process that you as a software developer will continue to update software until such time in the future when it's deemed unreasonable to update it any further. And that's what happened with the Internet Explorer version. Okay, we've done backward and forward compatibility. Now we're on to piracy and copyright. So we've done a little bit of copyright a couple of slides ago when we were talking about the author. But we have, it relates very closely to piracy. So piracy is when individuals illegally install software that they don't have a right to. And that can happen through actual purposeful acts of theft by going to a BitTorrent site and downloading the Adobe suite because you don't feel like paying several $100s a year to run Adobe, so you use an older system and you download them for free. That's purposeful piracy, or you could be producing CD copies of other people's software, and that's also purposeful piracy, but it can also kind of happen a bit by accident. You can think that that thing you found on the internet was free and then discover that it wasn't actually free. But that doesn't actually matter. You are required to know whether you have pirated software, and the law would find in favor of the person who was pirated from, even if you didn't really realize that what you'd done was software piracy. Okay, so intellectual property is the ideas and the fruits of mental labor, is what Sam Davis says, and it's ideas made into some kind of tangible thing. So for it to be to have copyright, it has to be written down. Software is written down, so software is covered by copyright, and that's how intellectual property exists. There are, as you know, ambiguities, and that's why there are court cases that determine whether it was actual theft of code or just similar ideas built on top of other ideas, whether it was reverse engineering or whether it was just building on observation. Those kinds of things are really difficult to determine, and you're not expected to determine them. You just have to give both sides of that kind of story. And that's why we looked at some of the cases that have existed. Plagiarism is, you had to go through a whole all my own work course at the end of year 10. So you know what plagiarism is. It's academic dishonesty by passing off somebody's ideas as your own. And it's just ideas in that case. It's not actual copy and paste of somebody's code. It's just using their ideas, which is where it becomes a little bit tricky, but it tends to be only in academic circles that particularly matters. Okay, more stuff on software piracy and copyright. We have classifications of software in terms of copyright, and we have done these to death, I feel like, so I'm going to go quickly. Commercial or proprietary software is stuff that's owned by somebody, published by somebody for money, and they really don't want to give you access to their code. And if you, there will be a license agreement, but it is 100% predictable that their license agreement says that you cannot reverse engineer their code, you cannot decompile their code, you cannot, steal their ideas. So that's the one that's completely locked down. Shareware and freeware are very similar. They tend to both be free to start with. Shareware tends to have some kind of time-based system, and you have to pay for it once you've decided that you will pay for it, that you're going to keep it. So this happens quite a lot. I have Sublime Text, that's shareware, and I love it, so I paid for it. Other people don't pay for it. That's unethical and kind of, no, it is illegal, but the chances of getting actually prosecuted for that illegality are probably slim, but it's still not the right thing to do. Okay, so they're very similar. They're the most similar. They are still covered by a license agreement. They are still owned intellectual property, and you will have a license that's likely to say, don't decompile my code, don't reverse engineer the ideas. But those are all managed by individual agreements, and so if they haven't been careful about writing their license agreement and they've somehow left a loophole that allows you to decompile or reverse engineer their code, then that's kind of their problem. But then we already know that these things are ambiguous, and if you get taken to court, it'd be tricky to defend. Okay. So then the other two that are kind of different and people get confused. One is open source, which says, I'm happy for you to use my code, change my code, make sure that the bits that I wrote are still accredited to me because I used that mental power to do that, and so I want to get credit for it. But you're allowed to make changes, you're encouraged to make improvements, and it's all the community trying to work together to improve code. The last one is public domain, and there are a couple of cases where things automatically become public domain, or it can be elected that a work become public domain by the author. So if I write a piece of software, I can elect that software become public domain, which means I don't care, I don't need you to accredit me, I don't care if you change it, I don't care if you learn from it, it's just free for everyone, isn't sharing fun. And so that doesn't need to be tied back to me ever. The other way things can become public domain is 70 years after my death. That is automatically public domain, and you'll notice that there's a lot of literature that falls into the public domain because we have a lot of literature that's old. Very little software is 70 years after anything happened. So you're not going to find a lot of software that is public domain because of time since death. Ada Lovelace is technically credited as being the first computer programmer, and she wrote a theoretical program that would run on a theoretical machine designed by Charles Babbage, and she was in the 1800s. So I reckon that her code, even though it wasn't real code, because programming languages didn't really exist, but that would be public domain. That's the kind of thing we're talking about. Okay, the last reason for public domain is if the author has somehow rescinded the right to own it, or if authorship is impossible to determine. And there's quite a famous monkey selfie case that happened a couple of years ago, where a monkey took a selfie with a photographer's camera, and the Wikimedia, the people who run Wikimedia, said that they didn't believe that copyright was owned by the photographer because the monkey used the tool and took the photo, so how can the photographer claim to own it? And that was taken to court, and Wikimedia won, but I believe that the photographer won on appeal. So these things, again, are ambiguous and difficult to determine, and you're not going to be asked to determine that kind of case in law in an exam, but you are expected to know what public domain means and how it can occur and what the impacts are. Okay, ownership versus licensing. So you don't own anything anymore. Well, okay, that's not entirely true, but if you buy a CD from a CD shop, you don't really own that music. It's kind of tricky to understand. You license the use of that music. So you can't burn that music. I believe there's some backup rules, but you can't make copies and give to friends. You can't remix it without permission. You don't really own that music. The publishing company and maybe the music artist owns that music. It's actually not all that often the music artist anymore. But yes, you can't just buy a CD and expect that means you can use that music any way you like. You can't even play it in a restaurant unless you buy a special public license. Okay, so the same thing happens with software. If you buy software, you don't own that software. You own a license for that software, and you should read your license because it tells you what you're allowed to do and what you're not allowed to do. And generally, there are very common rules like that you can't steal the software and use it in your own code, and like that you can make a backup, but you can't use the backup concurrent with the one that you purchased. So that's the difference between ownership and licensing. If you make your own music or make your own software, you own it, you can do whatever you like with it. You could, I guess, buy software ownership, but it would cost you a lot of money, and you'd have to negotiate that with the software owner, who is generally the developer or the development company. Okay, copyright laws. There are laws in Australia that relate to copyright, and you should know what they are. In general, you don't have to be able to quote from the Copyright Act, but you do need to know that it exists, and you need to know that you are, as a person who wrote something, in charge of who has the right to make derivative works, to distribute works, and to perform works or to display works, and that you have that right as the author, and you can then decide to give those rights away or to license out those rights. Okay, we covered this a little bit already in brief. This is the stuff in detail. Malware is malicious software, and misuse is doing the wrong thing. So we have viruses and worms and other malware that are covered in preliminary. We also have misuse, such as hacking, which is trying to exploit the weaknesses of a computer system, but generally via a computer network. So with the internet being ubiquitous, hacking has come to be something that is considered ubiquitous. But if you have a computer that is connected to nothing, has never been connected to anything, and is sitting in a room with a locked door, it's really difficult to hack that computer without opening the door and going in. Hacking generally is considered to happen across a network. Reverse engineering is taking apart a product. So sitting down with Microsoft Word and working out piece by piece how each part of it was made, and documenting that discovery, and then trying to replicate that discovery. So that is a manual process, and it requires you to still do a whole lot of the work creating code that is just very similar to that software because you have analyzed it in great detail. That's called reverse engineering. Decompilation is different. It's trying to use software to undo, uncompile a program. So take an executable program and try and strip it back to its source code so that you can then copy and paste. That's really hard. Even great software can't do that very well, but it can do it a bit, and you can kind of use both processes together to kind of steal other people's ideas. It's not a good thing to do, don't do it. But also know that it's not a good thing to do, and these are the differences, because they like to trip kids up with things like the differences between reverse engineering and decompilation. Piracy. What can we do about it? Not a heck of a lot, but there are a bunch of things listed in the syllabus. There's actually, depending on the articles you read, there's some sections of the world in which piracy is going down, and some sections in which it's ballooning at an extraordinary rate. These are the things that people try to use to limit piracy, and it's useful to some extent. So I talked a minute ago about Adobe Creative Suite and how people used to BitTorrent it from Russia because it's a very expensive piece of software. Well, they've kind of stopped that from happening now by making the Creative Cloud program something that talks to the internet constantly, and it's licensed on an annual basis, so you have to keep updating and keep paying money. And so even if you stole the software, the most amount of time you'd get out of it was a year. And even then, it's pretty hard to do that. So that's a strategy for reducing piracy. And the ones that are in the syllabus are non-copyable data sheets. This is an old technology that I used to have when I was straight out of school. We used to have games where you had to enter a random code that was written on the piece of paper inside the CD case, and they would say enter this code, this number, and you'd go to number 13 and find the code and then enter it manually, and it would then allow you to play that day. So that was to stop young people from passing burned copies of CDs around, which makes some sense because you have to have the piece of paper. But for a while there were a whole lot of photocopied pieces of paper that were also handed out with the CD. So that's basically what that is. It's just not terribly secure. Serial numbers. Everybody's entered a serial number. Generally, you have a serial number that comes with a piece of software that you buy from a shop, like physical software. These days with things like, most people don't buy software on CDs anymore. I don't even have a CD player on any of my laptops. I have to use an external when I need one from old technology for specific uses. So if you went and bought a game on a CD, then it might come with a serial number. I know that Windows comes with a serial number that is attached in some way to the documentation when you buy a computer, and so if you want to upgrade, you often have to enter that serial number. So this is kind of talking about before we had digital software everywhere. And this is also before we had the internet everywhere. So now things have moved on towards a bit more of that back-to-base authentication, which we'll talk about in a minute. So site license installation counter, if you run the network at a school, for example, then there might be a limit to how many licenses you bought for a piece of software, and there would be a counter to stop you from installing more than you actually bought. So if your school gets bigger, or if you're trying to save money by only buying 30 licenses for something, then they'll make sure that you only are able to install 30 and not a whole school's worth. And that's it's a way of saving money for schools, particularly if there's a particular piece of software, like maybe Premiere Pro. So really heavy duty video editing. It's really not used by everybody. It's only used by a limited number of people that are doing multimedia or arts media, and so they don't need a full school's worth of licenses. They only need a limited number of licenses, and that's how that would work. An encryption key means that without a code, it literally scrambles the data, so you can't do anything. And that is a way to keep things secure, but the times that encryption keys, whenever you make something that's meant to be secure, somebody on the internet somewhere is working really hard to undo it. So there were some news stories still a while back, so 5 years ago or so, when a whole bunch of encryption keys were just launched onto the internet for people to copy and paste, and it would undo the encryption. Also, encryption has to keep moving to keep getting harder to break because computers keep getting faster, and at the moment we have unbreakable encryption codes, but if new technology such as quantum computing comes on board, then those encryption codes are going to be useless. Okay, a registration code is where you activate software while you're installing. So you have to put some kind of code in through a process where there's a discussion between your computer and the people that you bought it from. And that's kind of masked in installation through Steam. It does a check to make sure that you actually purchase that software. So it's a little bit like what Steam does. And back-to-base authentication means that every time the application opens, it contacts the publisher's server to check that it's valid. And that's what Adobe Creative Cloud does. It uses the internet to keep verifying, is this valid software? Is this valid software? And you require a login and things like that. So that's very secure, and we're not able to find a way around that yet. People haven't found a way around it yet. It's a little bit different to how back-to-base used to work. In the early days, you actually had to hook up to a phone line. That doesn't happen so much anymore because we've got the internet. Moving on. Security. So encryption is the scrambling of data. In order to unscramble that data, you need a key. If you just sent the key at the same time as you sent the encrypted package of data, then the key would be readable, and so anybody who intercepted the transaction, the transfer of information, would be able to use the key against the encryption to decrypt the message and read it. That's bad. So there's this really interesting system of public and private keys, and I don't think I have enough time to go through it in detail, but there are a bunch of videos. I might post one to go along with this because it's a really interesting process. You don't need to know it in detail. You do have to know that there are two keys, a public key that you share with everybody and a private key, and the combination of the two keys means that you can be sure that your communications are safe. Okay, use of networks. Networks are a thing. I've already spoken about internet. So lots of software developers use networks, and we're talking about computer networks, but also social networks or human networks on those computer networks, and a lot of users use networks as well. So there are different types of issues to consider here. So if you have a network as a software developer, it opens up the world to you, and you've all used, as far as I understand, you've all used networks so far to make you better software developers by using Stack Exchange or any of those kinds of bulletin board sites where people answer questions for new coders. You are able to communicate with those people easily all over the world because the internet exists. If you were just sitting on a computer that wasn't connected to a network, then you would have to read a book to find out what you needed to know. And so that has made developers' lives very much easier. You can find out the answer to your questions really quickly. And it also gives you access to resources. Not just answers to questions, but libraries of code that you can then leverage within your own code, or entire GitHub repositories where you can go and learn from an entire project, or if it's open source, then contribute to it in order to learn. And so There are whole books on the internet, there's Wikipedia, there's tons of resources. So it helps with communicating across the world via either bulletin board systems or even email, Twitter, Slack, any of those things, or it allows you to access resources to help you learn. Now, from the user's perspective, if you're in a school, I'm using the school a lot because you guys know a school. If I talked about corporations, you wouldn't really be able to imagine working in one. So I'm going with school. So as a teacher in a school, we need to do reporting, and everybody needs to do reporting at the same time of year on the same system. And so we want to make sure that when we all jump on the network in November to madly write reports for the end of the year, that the system doesn't slow down to an absolute crawl because 60 people are all trying to do the same thing at the same time. So you have a responsibility as a software developer. If you are developing software that is to run on a network, you have to think about the kinds of things that impact users on a network, such as response time, making sure that things are secure and private because it is a network that is likely to be connected to the internet. We can minimize the amount of data that's being sent across the network to try and lower the traffic so that we don't have lots of blockages in communications, which reduce the blockages would add to the response time, and so we want to reduce the response time. The other thing is that there's you have to consider interface design when you're designing software that is networked versus software that is not networked. We need to make sure that we are not using very large, very graphic intensive interfaces that then have to communicate those interfaces across a network. There are some ways to do it where you run the client locally, so you can have really glossy software because the local machine is doing all the work to render those graphics. You don't want to have a web interface that has heavy very glossy graphics that take a lot of downloading because that information is being passed across the network. So you have to keep that kind of stuff in mind. Mind you, this is a syllabus that was written quite some time ago, and network speeds have improved drastically since then. So a couple of photos don't tend to make a huge amount of difference, but it does make some difference. So it's worth always making sure that you have made all of these considerations when you're designing software. The last point in this unit is the software market. The market is a thing, but it's not a place like a market you might go to on the weekend. It's like a fruit and veg market. It's just the virtual place where software is sold. So it's talking about sales, and it's talking about promotion, and it's talking about how to increase sales. And so there are a number of things that relate to marketing. And marketing is how we make people want to buy our stuff. So the first thing is the product. So you have to make a good product that people want, and it has to work. And probably the best way you're going to get people to buy your software is if one person uses it and they love it and they tell 5 of their friends. And then that happens again and again until you're Facebook and you've taken over the world. Just making sure that your software does what it's supposed to do and then continually improves so that it now does something that users think is fantastic and exactly what they wished it would do is how you are successful in the software market. The other thing is price. Now, price is a bit tricky these days because it used to be you tried to set a price that was not too expensive so that people didn't not buy your software at all because they thought it was too expensive, and not too cheap so that you maximize the profit you can get from people. But these days, this model has changed a lot, and a lot of software is given away for free, but the price is actually something that's not stated. So Facebook, for instance, sells advertising space to advertisers, and that's and the price that you as a user pay to use their service is your information, what you've clicked on, what you've liked, who your friends are, who you're connected to, what your geographic location is, what your gender is, what your relationship status is, how many people you've poked. Does anybody even poke anymore? What your Instagram account looks like. All of those things are owned by Facebook, and Facebook sells all of those things onto their advertisers in terms of demographics and even individualized advertising. So that's price. The other thing that is you have the model where you give away your software for free or for very cheaply, and then you charge people to use it by, and think of that as the Candy Crush kind of model. You know, people get frustrated, they've just died, they have to wait 24 hours before they get a life back, or they can pay $10 right now and get 1,000,000 chips. I don't know how that works, but it's something like that. And the latest Star Wars game by EA Games has been in the news and made people very angry because it's an expensive game. It's $100 or something, and then there were still in-game purchases, so you could still get better weapons or characters or something by paying money, and that seems like a scam. So price is a bit trickier than just what number will I pick, but it is still a very big part of how successful your product's going to be. So make a product that's really good and people really want, and make it at a price that they're willing to pay. And that's tricky science. Then we come up with place. Now, it used to be that you had to determine which stores would stock your product, where in the store your product would be. And if you think about a game store like EB Games, I guess that's still kind of relevant. You go and you still buy a CD. Generally, I believe that the CD then connects to a Steam account, which then downloads an absolute ton of data that doesn't fit on a CD, but you still get a physical thing, and that physical thing has been placed in the store somewhere. But that's becoming less and less how things work. It used to be kind of like, if you imagine Woolworths, there are racks. You pay for getting your product put in a good position. So each of those racks has some space that it sells, and those spaces are different prices based on their access to the person who's buying, to the consumer. So you did have to pay for that kind of place. Now, most software is done digitally without any kind of CD at all through systems like Steam, or through the manufacturer's website, or through there's a bunch of ways. A lot of software is free to try, and so the place becomes less a thing because the place where you sell the software is in the person's lounge room or on their phone. But if you do want to be on someone's Apple phone, you have to work out how to get into the Apple iStore, which is by no means straightforward. They are notorious for not allowing people to be in their store. Okay, next we have promotion, which is kind of what you think of as advertising, but there's all kinds of different media. So some software advertises on TV, very little software advertises on TV. things like, you'll see Apple advertised, but it tends not to be a particular software. It tends to be the whole product ecosystem to make you feel like you're part of something fantastic because it's Apple and isn't it magical. Google does some stuff that's similar. There was a PC versus Apple ad where Apple tried to make PCs look lame. There's Microsoft stuff. The big games, like I remember seeing an ad for Assassin's Creed, I think. There's stuff for the really popular phone apps, like I'm sure there's been a new Candy Crush app, like a witch thing, or there's been I think Arnold Schwarzenegger was selling a war game on your phone. Anyway, those are the kinds of things that are advertised on TV. Really limited number of games or software packages, because TV is broad reach, so it reaches everyone, from little kids all the way up to old people. And there's a whole lot of those people who are never buying your software. So you have to pay quite a lot of money to reach a really large audience, and then you're probably wasting a bunch of that money because a bunch of that audience don't care. So you have to come up with a more targeted way to reach people. Do you try and email people direct? Nobody reads email. Do you try and hook on to Facebook advertising or web advertising? Get set up with Google. Do you try and hook into the Play Store? If you win awards, sometimes that can give you promotion. PC magazines, that's a good way to promote, but magazines are dying, nobody buys them anymore, so how do you balance that? Places like Instagram and Twitter, if you can get a famous blogger to say that they love you, then that can sometimes help. These kinds of questions of how to promote things are really tricky to solve these days. There's a lot of people and it's difficult to reach them and make them care about stuff. And the final point is entrepreneurialism. So an entrepreneur is somebody who actually usually takes the risk and funds these kinds of things, like software projects. They have to be very good at managing things. They have to be good at networking with people. And sometimes they can win big dividends when companies get off the ground and they make a lot of money. And that happens with people like Bill Gates and Mark Zuckerberg and Steve Jobs. They're very popular. For every 3 of them, there's thousands who weren't very lucky. And sometimes that's because the software wasn't good. Sometimes it's just because there's a bit of luck of hooking on to something at the right time. And you can see that clearly because Microsoft brought out a smart watch 1,000,000 years ago, and everybody thought it was stupid, and nobody bought it. And then, within 17 years, 15 years, something like that, there's the iWatch that every kid wants to get, and Samsung have brought out watches that connect to your phone and your fitness tracker and everything. And people are kind of in a place where they're open to the idea now, but 15 years ago they weren't. They thought it was really dumb. So getting the right time is kind of important too. You don't need to know how to make very successful software. If you knew that, you don't need the HSC. You just go and make really successful software and have a wonderful life. The point is that this is a tricky decision. This is a tricky thing to solve, but you have to know that there are things that you can do to improve your software's chance in the marketplace. And knowing who you're marketing to, knowing who the people are that are going to use your software, knowing what they want, knowing how to reach them, these are really important. And how to employ good people and how to train good people, that's part of that whole equation. Okay, so that's a whole hour. We've covered the whole of Unit 1 in 1 hour. Please post any questions that you have, and I hope this helps you prepare for your first assessment task.